All right, so hello, I'm Derick. All right, so I'll be talking about Xdebug. Hello, I'm Derick. I work on Xdebug and have done for a long, long time. Hopefully I'll continue working on this for a long, long time, but we'll see how that goes. So I want to jump straight in. Hopefully most of you have heard of Xdebug. Yes, show of hands. Or rather, I should do the other way around. Who hasn't heard of Xdebug? Okay, one person. Oh. Okay, so very quick introduction. Xdebug is a debugging extension for PHP. If you haven't used it yet, install it, and your life will be a lot better. All right, to jump straight in, I'll be talking about this last talk of the day about what is new in Xdebug. So I've been working on this for a long, long time now, probably 17 years, and every new version of Xdebug usually has new features. These are new features that are requested by you, the users of Xdebug. Most of the time, not all of the time, but most of the time. So what I want to start with is something that came new in Xdebug 2.3. Now this is mostly a very simple feature, but I want to show that even though you might use Xdebug already, there are so many features in it that you might not be aware of. Now I can't go over all of them because Xdebug probably has like about 80 settings, and you'd just be very bored if I'd go over the documentation and point out every 80 seconds to you. So I'll make this homework for you. Go look at the documentation, figure out what is in there that I won't be talking about today. Okay, so one of the features that one of my friends requested, he works a lot with legacy code bases. Legacy code bases where there's lots of really crappy code in there. They don't always necessarily know what they're doing, or they're doing some really annoying things. So in this case, he was looking at this code base, and he found out that one of the libraries that this application was using would set error reporting to 0. So even though my friend was writing quite nice code, he never saw any warnings or any notices because one of the libraries used iniset to turn off the error reporting, which isn't particularly very useful if you want to see your warnings and errors, of course. So he asked me, well, can you do something about this? I said, well, I can't fix the code for you, but I can share as well other feature to Xdebug. So what I added is two settings. They are forced error reporting and forced display errors. And when you set those in PHP INI only, they override PHP's error reporting display error settings. So you can't, in PHP itself, change them so that you don't see errors and warnings anymore. Now, I realize this is quite a simple little feature. I just want to illustrate that even simple little features make a lot of sense sometimes, and if you have a good idea for them, I'm more than happy to hear. All right, so stopping about the little features, let's talk about some of the bigger features instead. So tracing in Xdebug is a way to figure out what happens in your application. I'm having a few demos. Live demos are always fun at the end of the day. I've been praying to the demo gods for quite some time today. And tracing is a way how you can basically figure out what else happens in your application. Not what else, everything happens in your application. So there are different types of output that it gives you. It's either textual, parsable, or HTML. What I mean by textual is basically you can see as a developer what happens. Parsable is a way for other things, like little scripts or computers to read what has been happening, and HTML is a format that I won't talk about because it's a bad idea, but I don't want to remove it. Okay, so the tracing, as I said, allows you to see everything that happens in an application. Well, if you have a very big framework-based application, then you might not necessarily want to see everything that happens in the framework because you just get too much information in there. Files that are several hundred megabytes are not unheard of. So it is possible to only do the tracing for specific bits. So if you want to see what happens in a specific action or a specific controller, you can do start trace and stop trace, and then only for that specific section will a file be created containing information. Now, it's nice to have a little slide about it, but I was like doing things better in live demos because I like to live on the edge. And in order to most of the demos that I have, I actually have installed a little browser extension. So I know this is going to be really small, but I can't make this bigger. So in the top here, there's this tiny icon. It looks like a little bug. And if I click on that, it allows me to select debug, profile, or tracing. Well, if selecting either of these then means that if your browser then makes a request again, it sets a specific cookie with a specific value that Xdebug reads, And when it sees this cookie, it then jumps into action. So if I turn on tracing, nothing really happens here. But when I now reload my slides, the slides are running in PHP HTML, otherwise this wouldn't work, of course. Let me try this once more for good measure. Then actually you see that it created a file here. It created a file called a trace file. Is that visible in the back? All good? Yep. All right, so what this actually tells you is a lot of different things. So in the first column, it's a time index since the start of the script. It tells you exactly how far along the script you've been going. So you see that it starts with 0.003. It takes a little bit of time to parse the first script as well, which is something you can't see in here right now. And then the levels of indentation tells you which function calls which function. So you can see here that the main body of the script calls require autoload. Most PHP applications now will have that single line. But if you go a bit further, you can see that, let me go a bit further. There's lots of lines in here. See the function easy template compiled code. You can see the class name here. You can see the method name here. You can see all the arguments, including their names. So this basically says that the first argument is called location. It has some stuff in there. There's another argument called context that has a class in there. As you can see, this is quite a long line. If you go all the way to the end, you can see where it was being called from as well. So it shows you functions being called, but it also shows you, like lines like this is variable assignments as well. So it tells you that in this case, options was set to a new value, an empty class like easy template options. It shows you return values to methods. So if you call MD5 on this one, it shows you the return of the MD5 statement, and so on and so on. And it does it for every single function call, every variable assignment, and every return value. Now, it doesn't show you all this information by default, because if you would do that, if you scroll to the end of the script, it's about 3,300 lines. 3,300 lines is not particularly very big, because this presentation system is quite simple. But there's a lot of information here. All right. So these trace files, if you look at these, as I said, you can see almost everything that happens in your script. The only things that it currently doesn't do, and it's something that I want to add, is that it doesn't do any things like looping structures in PHP. So there's no for each in there, which is sometimes handy to see as well, so that you can see where loops happen. From these trace files, you get to see, as I said, all the function calls, but it also, if you use the other format, the parsable format, it will be able to tell you how much time specific functions took. Because for both the entry point as well as the exit point of functions and methods, it will show you the time index. And by calculating all of these together and dividing them, you see how much time a specific function will take up during the execution of your script. So it's a very simple way of doing profiling and figuring out where things can be slow. Now, probably the main feature in Xdebug is its live debugging capabilities. This is a functionality that interacts with a IDE of any sort of shape, that allows you to, while the script is running, to see what happens under the hood. So just a show of hands here, I'm curious to see what editors people use nowadays. Who uses NetBeans? Okay, there's still a few. Zen Studio? Okay, that's nobody anymore. Who doesn't use PhpStorm? I said doesn't use PhpStorm, okay. All right, there's a few hands here. Do you want to shout out what you're using? No? Sublime, yeah, that's a few. Anything else? Any Vim users, Emacs users? Yep, a few hands, always a few. All right, so I'm guessing that most of you are using PhpStorm right now in that case, and that number has been increasing and increasing over the years. So it's good if you work for PhpStorm, I guess. All right, so because so many of you are using that, that's what I will be using as a demo as well. But the protocol that Xdebug uses is implemented by almost every IDE that you can find, every PHP IDE that you can find. And not only that, it is also implemented for many other languages. So it's implemented for Python and for Perl and for Tcl and for XSLT. I know, I'm sure nobody of you actually uses TCL or Tcl for anything anymore, but it's implemented there. And the interesting thing is that people don't always realize that in this situation, Xdebug is your client, your IDE is your server, because it is Xdebug that makes connections to your IDE to initiate the debugging connections. So that is something that is important to realize. So going back to the new features in debugging, before I go to try to give a live demo on this as well, is there's a whole bunch of additions to the protocol now. And these things only really work with the latest versions of PhpStorm. You need to have the 2018 dot something version at least for these things to work. So what I've added is that previously when you got an exception, you might get a breakpoint for that, but what it now also tells you is that exceptions, where they were called from, what the message of those exceptions were, and in addition to that, it now respects the inheritance tree of exceptions. So previously you could set an exception on, say, my exception, but it wouldn't break on any exception classes that were derived or inherited from my exception. So that is something that is now added to it. It will allow you to debug constants, the value of constants. Most applications don't really use constants anymore because they're sort of global, unmodifiable variables, but you'll be able to see those as well now. So those are some of the new things in here. In Xdebug 2.6, which is the latest version that came out, I've changed the connection timeout so that you can now configure it yourself. This is very useful if, for example, your development server lives in the US somewhere, and you with your ID are here somewhere in Europe, or your development machine is in Australia, because it takes too long, more than 200 milliseconds, to even initiate a connection. And for this kind of situation, it's sort of useful that you can increase this connection timeout. The extended properties functionality is something that sounds very simple. What it basically allows you to do is that you can now have array keys that have null characters in them. Now, hopefully not many of you do that by design, but it still happens sometimes. And the way how Xdebug's protocol works is it uses XML. And if you have a null character in XML, you can't do that. It's just not possible to have null characters in XML. So when this happened, IDEs usually would crash parsing the XML. Well, not crash like die on you, but get confused and drop the connection. So we changed that, modified the protocol to allow these kind of things. And interestingly, it will also do you all the notifications and warnings that usually would just show up in your browser window. It will now also send over the protocol so that you can see what's going on there as well. Now, with that said, a few words about activating the debugger if you haven't never done this before. So the only thing you really have to do is you need to use Xdebug remote _enable 1. In most situations, if your IDE runs on the same machine as PHP, everything will be fine and it should work out of the box. What I like to do is often set this extra setting. It's a remote connect back, which means that if your development server lives on your local network, the PHP built in or running in that development machine would uses the HTTP header information to figure out which machine made the request, use the IP address that comes out of there, and then automatically connect to your own machine that has your IDE running. So it is a nice little way of sharing Xdebug on a development server with multiple users or multiple developers. Now, activating the debugger, there's a few different things that you can do that with. On the shell, you need to export a environment variable. This is very useful if you want to debug like PHP unit tests and things like that, or all kinds of things that you run on the command line. It's a slightly tricky way of activating the debugger because, of course, there's no HTTP request, right? I can't easily detect whether that is something that happens. And then in a browser, I would use one of the extensions that I've listed here. I've already shown you the one that does the little tracing icon, but there's one for this live debugging as well. All right, I have a slide of PhpStorm in case my live demo doesn't work, but I like live demos better, so let's try that. All right, so let's turn off the tracing and let's turn on the debugging. Again, nothing happens here, but if I now reload the slide, live demo, I can unfortunately not see the last line of my slide on my screen here for some weird reason. All right, what should have happened is that it stops right in the browser at the first line of the script, which it did. So I've put PhpStorm in presentation mode, which makes the letters a little bit bigger, hopefully easier for you to see. Here in the bottom, sadly, it doesn't make the letters on the tabs bigger, which would be a nice feature. Hint, hint. But in the Debugger tab, you get to see on the left-hand side all the different functions that have been called so far, or how you end up here currently. Of course, we haven't called any functions yet because we just started debugging the script. And then on the right-hand side, it shows you all the variables that are currently available in the current function scope. So the first one is cookie. If I explode this, it says xdebug_session equals xdebug eclipse. The value of this cookie doesn't particularly matter to Xdebug. I guess the browser extension has selected xdebug_eclipse because I know Eclipse as an editor is very finicky about what value they have. Xdebug itself doesn't really care. There's also globals in here, which of course should be all the variables that you expect. In any case, the fun thing is that because the script has started now, I can go jump through this by calling the different buttons here. So there's one here that says, if it pops out, tooltip please, it says step over. And step over basically means go to the next line. So let's click that. And then you see that the blue bar jumps to the next line in your code, right? And after we've done a few, you see on the right-hand side that some variables have now also been set. So the TC one, template configuration, is now a new object that we've just created in 135 here. And it has a bunch of things in here. And then you can expand them to see what all the values of these things are. It's not particularly very interesting what it says here, but it's all in here. So, and yeah, if it's an array or an object, you can expand it to see what's in here. Now, there's also another button that is called jump in or step into. So if I click that a few times, I need to wait until I get into function here, or class definition. So in this case, you now see on the left-hand side that the highest function is main, start of the script, and the second one is the presentation construct. We are in the construct of the presentation object here. And then on the right-hand side, you get to see all the different properties again of all the different objects. Now, there's also continue running until the next bit. So if I click this, it will start running until the next breakpoint. So I misclicked there. So if I set a breakpoint in a barrier here by clicking on it, it would automatically stop on that line. Or what I can do is I can do right click, and then we can do run to cursor. So then it will run immediately to the line in the script that your cursor, or the cursor in your ID is then pointed at, which is all very useful to have this kind of stuff in here. If there would be any output, the output would end up here. Actually, I can probably run that by running the whole of the script. So then you see the whole output of the script here in HTML, which isn't particularly useful at the moment, but it is kind of useful if you have command line scripts to see what it outputs in that case. If there would have been a notice or a warning, it would have shown up in this console thing and will tell you which line and error these specific things were, and so on and so on. So this live action debugging is actually really useful. The breakpoints that you can set, you can even set conditions on them. So only break if the slide number is 33, for example. That means the application would only break if it's currently visiting slide 33 and so on. And lots of these things you can do in the ID. Now, I don't want to have my whole presentation to be about PhpStorm. I just want to show you, if you have never done this before, please go have a look at it because it makes life so much easier. All right, so let me stop the debugger, otherwise it's going to want to debug all my slides. Okay. All right, so sometimes, annoyingly, Xdebug also has bugs in it. I mean, not everybody writes, nobody writes bug-free code, right? Not even I do. And in some of these cases, if these things happen, then I need a reproducible case. Basically, an example how you can reproduce the bug in Xdebug. Now, sometimes the bug is in the ID, sometimes it's in the debugger, but without knowing how to get there, I don't know, right? So Xdebug has a setting called remote_log, and if you set that to a file, in this file it will record any connection attempt, which is something really useful for you yourself if you have some issues with trying to find out why the debugger doesn't start. Sometimes it's because it's the wrong port, sometimes because it's pointed to the wrong server, and so on and so on. Sometimes because there's a connection timeout, and it will tell you all of these things, why the connection didn't get started in the first place. If you have any sort of problems with debugging to get it started, turn on this feature and find out in the log file what actually happens. Now, beyond debugging debug connection issues, it is also possible to see every single thing that goes over the network in these files, which is very, very useful for me to find out particularly why debug requests don't work. Either Xdebug does something wrong, or the IDE doesn't understand something, and so on and so on. It's very useful for me to help you it's very useful for me to find and fix bugs that you find in Xdebug. That's lots of double up. It's confusing me even saying that. All right, so that's the remote debug log, the demo I've just done. All right, so the other big thing is profiling. And profiling is a way of determining which things are slow in your script. Although you can do that with these trace files that I've shown you a little bit earlier, that is very, very basic profiling. The format that generates isn't very, very efficient. It also had a lot of information in there that doesn't necessarily help you finding out slow things. Like, you remember it had all the variable assignments in there, and all the return types, and all the arguments. These things are very useful information, but in order for Xdebug to show you that information, it has to do quite a lot of work. Hence, enabling tracing, making your application slower. Now, the profiling part is specifically designed not to slow your application down, so it will not store you the arguments or the return values. The only things it will store you is how much time specific functions and methods took. It will store this in quite an efficient format that I even designed myself, which then can be used with a client, Kcache client in most cases, to then show you in detail what was slow in here. Now, I have 2 slides for that, but I'm pretty sure the demo is working, so let's do that instead. All right, so the trace files use a different file format as the profiling file. So again, I have to turn on a profiler here. So debugging, profiling, tracing is disabled, but I'll turn on the profiler. Now, of course, this is the least interesting slide to profile because it only has the word demo on it, but it should still give you a bit of an overview. So if I reload this now, I should get a different file here, which is called cachegrind.out. So this file, yeah, it has lots of gobbledygook in it. It's difficult for you to read anything in. That is fine. You're not supposed to read it yourself. So instead, I use a tool called Kcachegrind. If you're on a Mac, it is likely called Qcachegrind, and I'm sure you can find it for Windows as well. That is a very nice tool that visualizes these profiling files. So this is not an application I wrote. It's an application that was written to visualize profiling information for C applications. But I don't know how to write GUI applications, and I like to steal, or I should say, build on other people's work to make nice things, so that's what this does. Now, the information in Kcachegrind can sometimes be a little bit overwhelming, and in order to make a lot of sense out of this, it is best for you to play around with this yourself a little bit. First of all, I don't know your application. And secondly, well, every application is different, right? So, but I would like to give you a few pointers on how to use this. So on the left-hand side here, we have, for each function being called, it shows you the include time, or inclusive time. And in the second column, it says self. That is the time spent in that method or function. So inclusive means all the time spent in this function and every function called from this function. Now, interestingly, for main it says here, it only took 64%, which is a bit odd because it should be about 100%. I don't know why. This is not necessarily a bug in Xdebug. What this tool tries to do is it tries to figure out cycles in function calls as well. It doesn't always get it right, which is annoying, but so it goes. However, even getting these numbers slightly weirdly wrong, it still provides you with a lot of information. So in the top bit, you see all the little blocks here, right? All the blocks are functions that were called. The larger the block that you see, the more time was spent in that specific function. Now, if you see a large block like we have the green blob here, it is basically a function, or in this case a method, that took quite a lot of time, and most of the time was spent in just that part of it. If you look at the dark red one here, for the red one right here, or purple, whatever it is, that one also takes up a lot of time, but other functions that were being called from the function also take up quite a lot of time. So there's an indication that just lots of things are being done. Whereas the big green thing indicates that, well, this function on its own did a lot of work. So that is usually then a case to look at it in for seeing whether we can optimize that. Now, which function is that? Let's just click on this. We double click on it, and of course then we only get that function, so that's a bit boring. But, hang on. My buttons are falling off the screen here. Sorry, once more. I don't know, the resolution got a bit weird here. So if you go to the call graph, it shows you actually a graph of all the functions that were called from the start. So let me go back to main. You see in this big graph down here, especially specifically how often a function was being called. So it says this one was called one time, and this is it's difficult to see on a projector, but it basically says that the function or the file vendor autoload wasn't required once, and it took nearly 13% of the whole execution of the script. That probably makes sense because there's lots of functions being defined and lots of classes and methods and so on and so on. You see that a presentation display here took about 15% of the time. Now, in order to find out which functions took up a lot of time, you basically need to find, by clicking around this, by looking at different functions, the one that has a very long line downwards. Because that usually indicates that a specific function in this long line takes up a lot of time. Now, this presentation system has been optimized sufficiently so that you can't really find these anymore, but that's what's in here. You can find interesting things in here. So there's a few other things in here as well. There's a source code tab that shows you per line which functions were called and how often. There is a all callees map. So an all callers map is here. That tells you basically, let me find a slightly better one. So I selected PHP simple XML element to string here. And it shows you that, well, it was called 3 times directly from main. It was called 50 times from presentation construct and so on. So it shows you in like a range where all those functions were being called from. As I said, the information that kcachegrind provides you with is quite overwhelming sometimes, but there's so much good useful information here. And it is particularly useful for when your application is still in development. The provider does a lot of work, which also means that it takes up quite a lot of time to do. So your application does slow down a little bit, but it's all relative, so the information it provides would still be very useful. All right, I have 10 more minutes and 73 more slides. That was a joke, don't worry. All right, so Xdebug 2.3 also comes with something like paths. If any of you have used PHP unit with code coverage, just a show of hands. All right. So how many of you have 100% code coverage? Okay, a few brave souls raising their hands. Well, let me tell you, 100% code coverage is still a lie. All right, so let me demonstrate why does this. So if you see this little script here on top, it has if then else with 2 independent if conditions. You can cover all the lines by doing 2 tests. Right? You can set A is true and B is false, and you can set A is false and B is true. And that means you cover all the lines, all the possible branches in your tests are now being executed. But what you haven't tested is all the possible paths through it. So when you would run this thing with PHP code coverage, you get a result like this. Woohoo, 100%, everything correct. But that's a lie, as I just said. Okay, so Xdebug 2.3 comes with a new feature called CC branch check. This is not something you'd ever have to do yourself. This is something that PHP unit and PHP code coverage will do for you, but there's this new setting. And that makes Xdebug returns a whole lot of information about all the different possible paths, branches. So an if statement will create a true and a false branch. Combining all these true false branches creates paths. So in this case, what Xdebug says is that there's 4 paths, which correspond with A being true and B being true, A being false, B being true, B being false, A being true, and both of them being false. Right? So those are the different options. And as you've seen, we've only run 2 tests. So it now nicely says that only 2 of the 4 paths have been hit, which then tells you that you only have written about half of the tests you really should have done. Visualizing that is kind of complicated. So the visualization that I've done here is I've created 4 lines, a solid line being this path is being followed, or a dash line where it hasn't been followed. The op numbers in there and line numbers are a representation of PHP's internals. It tells you, well, maybe not you, but it tells PHP what the possibilities were, and it helps Xdebug figuring out what all the different paths are. The visualization of this with 4 possible paths is quite simple, because I can draw 4 lines in 4 different colors. But you must realize that every time you have an extra if statement or for loop, you duplicate the number of paths. So if you have 10 if statements or for loops in a function, you end up having more than 1,000 different lines. You cannot see with the eye 1,024 different colors. So the visualization is a big problem here. Although I've added this feature as a request by Sebastian Bergman, the author of PHP Code Coverage and PHP Unit, I implemented about 2 years ago. He hasn't come up with a nice way of visualizing this, which is kind of annoying. On top of that, it's really, really slow. It is so slow that doing this instrumentation for every single function easily makes PHP running code coverage, which is pretty slow in the first place, it easily makes it 20, 30 times slower, up to the point where it's pretty much not usable, which is very sad. Of course, where this is really important to this branch and path coverage is only for very specific, very business critical parts of your application, right? You wouldn't want to do this for very simple things because it just takes a lot of time and it doesn't actually help you very much. The things that you need to have lots of code coverage about is your complex algorithms that are very important for you to test. Okay, so Q on. I'll go forward through time a little fast. Xdebug 2.4 had support for PHP 7. Hopefully you're all using PHP 7, right? Yeah, I see everybody nodding their heads. No, I didn't, but... Xdebug 2.5 brings support for PHP 7.1. You're on PHP 7.1, right? I see everybody nodding again. Yep. Then we had our 15th anniversary. Somebody sent me whiskey. That was really nice. But the latest version is Xdebug 2.6 that came out early this year. It has support for PHP 7.2. It has no longer support for PHP 5. I do not intend to maintain PHP 5 support on Xdebug anymore because it basically duplicates the amount of work that it costs for me. And everybody was nodding their heads when I asked whether you're on PHP 7, so clearly it's not necessary anymore either. All right, so what I also added to Xdebug 2.6 is some cleverness. Okay, one thing I should talk about before I go there is that PHP 7.2 has lots of very nice bits of optimizations in here. Before PHP 7.2, if you would do a switch statement, if you can read PHP internals, the bottom tells you a little bit more. But what basically would happen is what it would do is like, if A equals 1, do this. Else if A equals 2, do this. Else if, you know where this is going, right? It will do an if-else statement for each of your switch statements, which is not clever. PHP 7.2 now has an optimization in there that it just looks at the value up front, has already calculated a jump table to jump to the right parts of PHP's internal structures so that it doesn't have to do the if-else statements anymore. Which is really nice, because it's a lot faster, but it does mean that Xdebug no longer can see all the different cases that have been hit or haven't been hit, so the code coverage information that it provides is now not good anymore. So unfortunately, if you run PHP 7 with Xdebug, I actually disable this optimization so that code coverage can give you the right results, which is kind of weird. The graphs internally goes from this to this, but you get to look at the slides yourself later because I've uploaded them. Anyway, in order to combat the slowness of this path coverage, Xdebug 2.6 has another big feature in there, which is filters. What the filter allows you to do is basically restricts the amount of work that Xdebug does for specific things. So these specific things are code coverage or stack traces and function traces. The stack traces are the ones that show up when you have an error. It's the big orangey things. You probably have seen those before, right? And the function trace is the one that I showed you earlier. So these restrictions, with these, you can tell Xdebug not to do work for either specific directories or specific namespaces or class prefixes. There's different modes in here. You can either do it by path or by namespace, and you can use a blacklist or a whitelist. With a blacklist, you disable specific things to be done for specific paths or classes, or use a whitelist to configure for which things Xdebug only should do work with. It's better to show you that in an example. Actually, the invocation is here. So what the set filter does is, in this case, I set the filter for tracing. I set it to a namespace whitelist, and I have 3 elements in my whitelist. The empty string means PHP internal functions. Need to come up with some way of doing that. And then I have dram, which is a prefix to one of my Whiskey applications that I've written myself. And then it's the namespace MongoDB. So the / is important here, because without the slashes, it would also, for example, match, like in dram, it would mean, can't come up with a good example, but if the letter A would be behind dram, it would also match for that. If you have the slashes there, it wouldn't do that, and so on and so on. As an example, if you run this on one of my test suites, before using this filter, it took nearly 4 minutes and 56 megabytes of memory. With the filter enabled, it was about twice as fast. So if you use code coverage in any sort of way, you definitely want to have a look at these filters. The filters only work, unfortunately, there's always a but in places, right? They only work if the filter is set before code has been included. Which means that at the moment, it's not possible yet for PHP unit to set these filters and then run your tests, because the moment PHP unit gets to the point where it can set the filters, it has already loaded all of its code. In which case, the filter is already too late because the code has already been instrumented. So that's kind of annoying. But there's a way around this, is by using an auto prepend file. So in this case, I'm using PHP unit 5.7 here. I only want to do the instrumentation for a specific bit, so I create this auto prepend file that sets the filter to only do code coverage as a whitelist for this specific part that I've specified. Again, important to have the slash at the end here. And when I then start PHP with this auto prepend filter before running PHP units var, you get this 2 times speed up, which is something you definitely want to have a look at if you're running code coverage, because you have to wait a lot less, which is always fun, of course. It might mean that you need to make coffee faster, but so it goes. All right, so those are the new things in Xdebug 2.6 and previous versions. That's about as much I had to tell you about. Xdebug is open source and free, as in free beer. I like free beer. Xdebug hopefully saves you a lot of time. It also takes me a lot of time to write on. I've recently started opening a Patreon account where, in case you feel the need for it, you can give me $1 a month or something like that, or more. It's also good, of course. If not, that's totally fine as well. You can also help out Xdebug's development by, if you see a bug report, don't whine on Twitter, send me a bug report. It's always good, because if I see on Twitter, I don't see them. If you have any questions, feature requests, I'm always very happy to hear them as well. You can email me, or you can use the bug tracker or whatever. That's about what I had to talk about. Are there any questions?